Hello, I'm Dr. Rosemary Francis, Chief Scientist here at Altair. Today I'm going to show you how easy it is to run MPI jobs in containers with Altair Grid Engine. Because of complexities in the networking layers, it's often believed that MPI is hard to run in a containerized environment, but hopefully today I'm going to show you how easy it is by leveraging both the integration between MPI and Grid Engine and also the built-in support for Docker containers in Grid Engine. I'm going to show you a very simple demo setup. We've got Altair Grid Engine and we've got two nodes called Node 10 and Node 11. I'm going to launch an MPI job on Node 10 inside a container. It's going to run a single rank with a helloworld application, and it's going to launch a second rank inside a container on the other node, Node 11. The command to run this is quite long, as you can see, but it's not very complicated, and we're going to break it down. First of all, you might notice I'm running QRSH instead of QSub. To make it easier to demo, I'm running an interactive job, so I'm going to run MPI run explicitly. You would normally run a QSub job with MPI run launched automatically. The next part of the command is the parallel environment. I have a parallel environment called Docker setup. I'm requesting two nodes. I can see the details of that parallel environment. PE name is of course Docker. And you can see in the qconf configuration, the allocation rule for this parallel environment is to fill up. That means that Grid Engine will try to fill up as many slots on a machine as it can before it moves on to the next machine. Now I want my two containers to run on different machines, and so I've overridden that setting with the -PAR1 setting, which asks Grid Engine to run one slot on each machine. The next part of the command is about selecting the Docker images. The first command, Docker equals 1, tells Grid Engine that this is a containerized job. The next is Docker images selects the Docker image that I want to use. You can run the command qstat -f Docker images to list the images installed. You'll notice the extra argument -soft. This tells Grid Engine to fetch the image from the Docker repository if it's not already installed on the machine. Once it's been fetched the first time, it'll be cached on the machine, and so you don't need to do that. The next -d switches are all external Docker arguments. The container doesn't know about users and permissions, and so we have to pass that information into the containers. We're also going to tell Docker to use the host network, and we're also going to mount the home directory. The final argument mounts the GE directory because that's where the MPI libraries are installed. So now let's take a look at our Hello World MPI application. This is just a simple Hello World application from Indiana University. It's been built to understand Grid Engine. This is very straightforward. Just when you're running your /configure, you just put in the argument with SGE. And MPI has been installed on the machine in this case, but it could equally be installed on the container, in which case you wouldn't need to mount the GE directory where MPI is installed. Taking a look at our sample application, you can see it's very short, fits on one screen. We have the MPI init and MPI finalize at the beginning and the end. Then we have three printf statements. First of all, a hello world, then two printf statements telling us which rank and which host we're running on. So now let's switch over to the demo. First of all, I'm going to run the command that we've just gone through. It takes a moment for the container to start up. Now we're launched in the container, all on Node 10. I'm going to run the MPI command. So there you can see we have Hello World running on both Node 10 and Node 11 with rank 0 and 1, both saying Hello World. Thank you for listening. Hopefully I've shown you how easy it is to run MPI applications and containerized workloads on Altair Grid Engine.